All right. Hey everyone. So this is day 17 of Math 133. Today is July 14th, and we are going to talk about the Chapter 9 project. Okay. So don't forget to do the lecture notes. So we're going to start Chapter 10, so 10.1 lecture notes. There's also lecture notes for Chapter 9 flowcharts. So it's not a particular section, so it's not 9.5 or 9.3 or anything like that. But if you do click on it, and it'll have the videos in there, you'll still go and out the lecture notes for this part. Okay. So the videos are here, or you can click it and go to YouTube. Okay. Yeah. Yes.
Guys, those
Um,
are very, very, very helpful. Those are really, really nice.
Yeah, so yeah, it's not like I said before, it's not new. It's not like a 9.5. It's not necessarily new information, but it is super helpful. So try to do those lecture notes before tomorrow because Cindy is going to use information from that in her class tomorrow. But for today, we're going to be looking at the Chapter 9 project. The Chapter 9 project is going to use it's going to come from your
Only thing
course
is, you
pack.
might have to call her again because it wants to send a six-digit code to one of the phones, and
Yeah.
obviously you can't send it to this phone.
The page in the course pack for the Project 9 is going to be page 532. Okay. Also, for this project, you're going to need the information that you gathered uh, last time when we talked about candy. We did M&Ms and Skittles, and we did some counts. Um, uh, our candy's gone. It's fine if your candy all got eaten, but we're just going to need the counts for that. If you go to Google Drive and you click on Recent, it should be near the top. So here, for example, this one is mine. You want the Candy Project data and graphs. Okay. Um, and that's going to be this one. Okay. So it's got all my counts, how many I had for orange, green, for M&Ms, as well as everything for Skittles. Okay. Um, okay, great. Uh, we're going to start though on page 532. Okay. In our course pack. And we are going to be doing this is for chapter 9, and chapter 9 is all about confidence intervals. Okay, so confidence intervals. What we're doing is we are building a range. A confidence interval is two numbers. It's a low number and a high number, and we're going to say that the probability that our actual parameter falls somewhere in that confidence interval is the confidence level. Okay, so normal confidence levels would be like 95%, 99%, things like that. So 95% of the time, the parameter is going to fall in this range. Okay. Anyway, okay, page 532, though, we're going to start with this. Start with our name, put that in there. Okay. Um, okay, so then looking here, which M&M color had the lowest in your sample? So I'm gonna go look at my data. Now my data, I had 12 yellow. Okay. Yours is probably going to be a different number, of course, or actually it better be a different number because you had different bags, different counts. And so the bag of M&Ms that you collected, that represents your sample. Okay. And that's the sample out of the population, which is all M&Ms. Okay. And uh, your sample size is your total right here. Okay. So mine had 12 for yellow. So I'm going to write right here yellow. Now, if you had uh, a different color that was low, that's fine. That's great. Okay. Um, but I want to be careful here. If you had a zero, okay, meaning you had no browns at all, we're not going to want to use that, okay, for our low number. Use the second lowest in that case, okay? If you had a zero in here, don't use that one. Use one that's higher than 0, okay? If you had a 1, that's super low, and it's really going to mess with the numbers. But you can absolutely do it with 1, okay? 2, 3, 4, 5, any of those are going to have some crazy numbers, okay? If you had two numbers that were both low, you can pick one. It doesn't matter to me, so either is fine. Okay. Yeah, if you have a 7, that's fine. Okay. If you have numbers that, as long as it's not a 0. Okay. Um, all right. Anyway, so the reason why is because you'll remember that uh, there is a formula for your uh, there's a formula for your confidence interval, right? It is it's not this one. Where's my confidence interval? So it's right here. Okay. So my p hat plus or minus my z value times the square root of p hat times q over n. Now, if you have a 0, then that means that your p hat is going to be 0. Okay. So that's fine here, 0 plus or minus this number, but you also have another p hat right here, which is also going to be 0. So you're going to get 0 plus or minus 0, which is going to just be a confidence interval of exactly 0. Okay. So that's going to make no sense. Okay. All right. So if you have to use one, that's fine. There you go. So uh, let's jump back over here. Okay, so mine is yellow. Okay. Next, we want to know our x, and x is the successes. So x is the number of your color. Okay, so in my case, it's how many yellows I had. N is your sample size. Okay, so that's going to be the total in the bag. Okay. All right. P is going to be x divided by n. Okay, that gives you p hat. Okay, that's the estimate. That is the statistic for the probability. Okay, the probability of yellow. Okay, so if I was to randomly select a M&M out of the entire population of all the M&Ms in the entire world, what's the probability that I get a yellow? There's a probability for that, and that's the parameter. My p hat is a statistic which is going to estimate it. Okay. All right, so with that in mind, verify that all the requirements for constructing confidence interval for the proportion of this color are satisfied. So we'll start with random, okay? And that one is a yes, but it's not yes given, right? Because in here, so if I was doing, for example, if I was doing a sample, a random sample of things, so right here, I have the word random, okay? For this question, we don't have random in here, so you need to explain why it is random, okay? All right. Next is independent. Okay. And for independent, the answer is also going to be yes, okay? And that's because our n has to be less than 5% of the population size, okay? Or you could do it as 20. So 20 times n, that needs to be less than the population, which in this case is all what, okay? All right. Last one is norm, okay? And this is where things are going to fall apart, okay? Because in order for it to be normal, okay, our n times p hat times q hat has to be, that's going to give you some number, okay? And that number has to be greater than or equal to 10, okay? And if it is, then good. then that means you have a big enough sample. Your sample is large enough that you can build a confidence interval that's going to be accurate. Okay. On the other hand, if you do this and you get a number that's less than 10, okay, then your answer is going to be no. Okay. That means that the confidence interval that you're going to build can't really be trusted. Okay. It's not going to be, uh, it's not going to be likely to be useful. Okay. Um, so p hat, that's going to be uh, x over n. So it's the probability of getting, in my case, yellow. Yours might be a different color. Um, but it's basically the number of successes. Okay. So if you're already below 10, then you're definitely going to get a no. Okay. So if you're at 1, you have 1 brown, then it's going to be a no. Okay. That's okay. We can still do this project. Okay. But it's important to keep in mind that things are going to break down a little bit. Okay. So your numbers are going to be, like I said, not necessarily trustworthy in terms of like something that you could actually use at your work, or in the real world. Okay. All right, moving on though. For this part, we need a random confidence level. Okay. So for the confidence level, what you're going to do is over here in Canvas, we'll click on Project 9. And there is a link that's going to, if you click that here, it's going to take you to StatCrunch. Make sure that you sign in. Okay. Once you've signed in, it's going to bring you to a page that looks like this. Okay. So here are a bunch of different confidence levels, okay, that we can use. And you're just going to pick one at random. And actually, you're going to have StatCrunch pick it for you at random. And the way you're going to do that is you're going to start by going to Data, Sample, click on Confidence Levels, and you're just going to do a sample size of 1, okay? So Data, Sample, Confidence Levels, sample size of 1, and hit Compute, okay? And whatever number it gives you right here, that's going to be your random number, okay, that we're going to use. So mine is 86. So I'm going to use right here 86%, okay? And yours is going to be different, okay? So whatever confidence level you got there is fine, okay? Okay, cool. So what that's going to mean is going to tell me how accurate my confidence interval is going to be. Okay. So I said earlier that if your product right here, if you multiply these together and you get a number less than 10, your confidence interval is not going to be accurate. Okay. It's not going to be trustworthy. But even my confidence interval that I'm going to build, even if it's a yes, it's only going to be 86% accurate. Okay. Um, You'll notice that in here, the number 100 is not in here. Okay. The only way you can have 100% confidence is if your sample size is the same size as your population, meaning you talk to every single person, or in this case, you check every single M&M in the world. That is the only way you can be 100% confident. And that's not possible a lot of times, okay? So it's possible to do 99%, okay? Or even 99.7. 99.7 is 3 standard deviations out, and we can do that, okay? But in order to be 100% accurate, you have to have a sample size that's just not possible. Okay. So that in mind, we're going to go on to page 533. Okay. So here on page 533, regardless of whether or not the requirements were met. So even if you're below 10, we're going to keep going. We're going to make ourselves confidence interval. And so there is a formula for that. You'll find that formula on page 237, and also on page 189. Okay. You'll write out the formula with the letters, okay, and then you'll substitute in your numbers. Okay. and then you'll do the math, gives you a result, okay? And your result is going to be two numbers, okay? A low end and a high end for your confidence interval, okay? All right. So you'll write it like this, just like that. Lower limit, upper limit, okay? So that's going to tell you where that parameter for the entire population is going to fall. It's, in my case, an 86% chance that the parameter that I'm measuring is in between these two numbers, okay? And the number that I'm measuring is the probability or the proportion of yellow M&Ms in the world, okay? All right, so you do that, and then Willy Wonka claims
Joe,
that.
is it
Go ahead.
okay if they just, I'm sorry, is it okay if they just go to StatCrunch to get their result by doing stat, proportion stat, one sample with summary? That's how
100%.
I think how Alana showed him how to do a result.
And that's
I
what
mean, you
we're
can do the math, you can use Desmos, but
yeah, and we're going to actually show both ways to do it. So, yep. So the substitution right here is basically you just put the numbers in, okay? So, it's going to look something like this, where, you've got your formula, and then you'll put in the numbers, and then you do the result, okay? So here I can take these numbers and I can either put them into Desmos, or I can take these numbers and I can do it in StatCrunch. But either way, you're going to get the same result. Okay. And it's actually this one. This is maybe a little more accurate right here. Okay. So it's going to look like this. Formula, not exact same formula with numbers, final answer. Okay. Okay. Okay, so Willy Wonka comes and he talks to you and he says that the proportion of candies of your chosen color is less than 1/6 for any bag. Okay, so not just yours, for any bag in the world. Okay, which is basically saying that the proportion of yellow candies in the entire world is less than 1/6. There's 6 different colors. So if M&M, or I guess M&M is owned by Mars Corporation. If Mars Corporation is making sure that every single color is produced in equal amounts, then Willy Wonka's claim is incorrect. Okay, but he's claiming that they're actually skimping on the yellow ones. They're actually making less yellow than the others. Okay, so in other words, he's saying that it's less than, okay, whatever the decimal is for 1/6. Okay. So we're going to check and see if that's correct or not. And that's based on whether 1/6 is inside the interval that you created, or whether it's below or whether it's above. Okay. Um, so yeah. Okay, once you've done that, yes, and we're definitely going to do through these tonight. Okay. So at the moment, we're just reading through, giving you some hints on how to do this. We'll stop the recording in a second, and then we'll go back through and we will do this together. Mhm. Okay. Suppose you had a super big bag with thousands of M&Ms. So, or maybe you maybe you did. If you bought the 1 pound container, you might have gotten up to 1,000. But anyway, so the proportion of your color is the same as a number one. Okay. If that happens, is your confidence interval going to be narrower or wider? Okay. You'll find information on that on page 189 at the very bottom. Okay. All right. Moving on to page 534. So next, we're gonna do Skittles. We're gonna switch over and we'll do Skittles. And this is really gonna follow the same kind of steps. Okay, to be honest. So the only real difference is you're gonna look at the highest count instead of the lowest. Okay. So I don't really need to worry. It's gonna be the same stuff for all of this. Down here, we'll do another random confidence level. So we'll do that in StatCrunch. So we'll come back over here to StatCrunch. And we're going to pick one of these numbers at random again by going to data, sample, confidence levels, and do a sample size of 1. Okay. Data, data, come on, data, sample, select your confidence levels, sample size of 1. And it's going to put it right here. So mine in this case was 81%. Okay. So I'm just going to put that right there for me. Okay. And yours is going to be different. Okay. Yours will be a different number, which is fine. Okay. So we're going to use 81% for Skittles for me. On the next page, which is page 535. Okay. Same thing here. Okay, so Willy Wonka's back again. He's bothering you again. And now he's claiming that the proportion of candies of your chosen color is more than 20%. Okay. So for any bag. Okay. So um why is it 20%? Well, 20% is 1/5. Okay. And that's fine, Ashley, if yours is the same as anyone. So 1/5 is 20%. There are 5 different colors, so that's why he's saying that. So okay, anyway. So state the confidence levels that I found. So mine was 86% for the first one, and then 81% for number 9. Okay, you just copy those from number 3 and number 9. But then you want to know, okay, which of these confidence intervals is going to be narrower or wider? Okay, so you'll find information about that on page 189. Okay, it's going to talk about down at the bottom. Okay. All right. One last page, and then we will jump in and we'll actually finish this project tonight. Okay. All right. So back to M&Ms. We're going to use StatCrunch to get another random confidence level. Okay. So we'll do that back over here. Same thing. Data, sample, select confidence levels, sample size of 1. And this time I got 89%. Okay. By the way, if you get 3 numbers that are the same, or if you get any of them that are the same, okay, nice. If you get any of them that are the same as each other, so like if I had gotten 86 again or 81 again, um, I'm gonna uh, I'm gonna throw that out and pick a different one. Okay. If you keep getting 81%, switch it because it's gonna mess up one of the questions down here at the bottom otherwise. Okay.
So Joe, that might be that Ashley, when she's doing that, is picking not the top on the confidence level, but she's picking like the 81%, like when you go
Yeah, so when
at
I go data and I go sample, I need to make sure I'm selecting confidence levels because if I select this one, it's that column is this column right here, this third column, which is an 81, so I'm gonna get 81 again. Okay. So don't do that. Okay. Uh okay, so I delete this guy. Okay, there we go. All right, sounds good. So you got something different. So that's good. Okay, so calculate the minimum bag size as in number of candies required to ensure that the proportion of your color, in my case it was yellow, of M&Ms is within 2% of the true population for that color. Okay, so this is my error. Okay, use the confidence level from number 13, which I got 89%, and assume you do not have a prior estimate. Okay, so there's a formula for that. And the formula for that is on page 190. Okay. You'll also find it on page 239, which is the yellow exam notes packet. Okay. But you'll find a formula for that. Okay. So during this chapter 9, so one of the confusing parts is there are a lot of percents floating around. Okay. There is your confidence level. Okay. There is your error rate. Okay. And if you're doing your proportion, which in this case we are, a proportion can also be seen as a percent. Okay. In our case, M&Ms, we have 6 different colors. So 1/6 is like 17%. Okay. So that's going to be the parameter that we're shooting for. And our statistic is going to land somewhere around that 17%. But if I wanted to get within the actual parameter, okay, I might be 2% plus or minus, okay, give or take, right? We've used in the give or take phrase before, where my proportion might be 17%, give or take 2%. Give or take means maybe it's down 2%, so it's 15, and maybe it's up 2%, so it's 19%. And that's what my confidence interval is. It's basically measuring the give or take distance between the two ends, okay? So I'm basically taking my mean and I'm actually doing the addition of 1 standard deviation or 2 standard deviations or whatever. I'm actually doing the addition going up or going down. Okay. All right. Anyway, number 15, suppose that when completing number 14, you used an error rate of 1% instead of 2%. Okay. So you'll look on page 190 and it'll talk about the relationships between the errors and what will actually happen with your sample size. Okay. All right. Calculate the minimum bag size again with the same confidence level, but this time you have a prior estimate. Okay. Up here, we're going to have no prior estimate, and there's a different formula. It's very similar, but a different formula if you do have a prior estimate. And the formula for that is still also in the same place, page 190. Okay. And in this case, we do actually have prior estimate. So doing this one up here where we said, oh, you don't have a prior estimate, is actually inaccurate. Well, I mean, it's not inaccurate, but it's going to make things a little worse for us than if we actually use a prior estimate. Okay. All right. Finally, state the confidence levels from number 3, number 9, and number 13. These are just the ones that I got. Okay, you might get different ones. Okay, I actually got all 3 in the 80s. That's interesting. And you'll find, again, on page 190, information about how the sample size is going to affect your confidence level. Okay. All right, cool. So I'm going to stop the recording. If you're watching this on the recording and didn't get a chance to come to the class, don't forget to fill out your discussion board. If you're here in class, you don't have to do that. And we're going to go back through this and make sure we understand how to do this project. Okay.